1944, Adak Island, Alaska. Rows of Caterpillar D7 bulldozers sit in fog and salt wind at the edge of a wartime airfield. Blades down. No operator coming back. They helped build one of the most urgent bases in the Pacific. Then the war's math changed. To understand why nobody went back for those machines, you have to go back to Adak in 1942 and 1943, when the island stopped being a forgotten volcanic outpost and became a military emergency. Adak sits deep in the Aleutian chain, nearly 1,200 miles from Anchorage and far out in the North Pacific, where weather behaves less like climate and more like an active enemy. Wind comes hard, and without warning, fog closes visibility to almost nothing. Snow, sleet, and salt spray move sideways. The ground is wet, cold, unstable, and rarely still for long. Before the war, it was not a place Americans thought about often. During the war, it became essential. That change came fast. In June 1942, Japanese forces occupied Attu and Kiska at the western end of the Aleutians. The occupation shocked the United States not because those islands were heavily populated, but because they were American soil and because the Aleutian chain suddenly mattered as a route, a shield, and a forward edge of the Pacific War. The U.S. military needed airfields farther west, and it needed them quickly. Adak, though bleak and exposed, offered one thing that mattered more than comfort. It was close enough to support the push. The problem was that Adak was barely a construction site. It was a wet, treeless island of tundra, volcanic ridges, muskeg, shallow lakes, and soft ground that punished any assumption brought in from the continental United States. On paper, engineers could mark out roads, camp areas, fuel storage, and runways. On the ground, conditions changed everything. The island absorbed weight badly. Drainage was poor. Frost, thaw, and saturation turned simple haul routes into traps. A machine that looked oversized on a stateside job could suddenly seem underbuilt when its tracks began to settle into black, waterlogged soil under a load of wartime urgency. That is where the Caterpillar D7 entered the story. By 1943, the D7 was already one of the most useful crawler tractors in American service. It was not the largest machine in the military inventory, but it had the balance the Army and Navy needed for expeditionary construction. Roughly 80 horsepower depending on configuration, diesel-powered, track-mounted, and compact enough to ship in quantity, it could grade, tow, clear, and push under conditions that stopped wheeled equipment cold. In a place like Adak, that mattered more than raw size. The job was not simply to move earth, it was to keep moving at all. Military engineers, Navy construction forces, and civilian-linked war contractors were all part of the Aleutian buildout. Men, fuel, steel matting, tents, pipe, generators, rations, and bulldozers had to cross enormous distances by ship before any runway could exist. Every gallon of fuel burned by a D7 on Adak had already survived a supply chain stretching across dangerous water. Every replacement part was late the moment it was needed. Every breakdown on the island was more serious than the same breakdown in California, Oregon, or Washington, because there was no nearby dealer yard, no easy rail shipment, no comfortable reserve of mechanics and inventory waiting over the next ridge. The urgency was absolute. Adak's airfield development was tied directly to offensive operations against Kiska and to the larger effort to regain control of the Aleutians. Aircraft needed somewhere to land, refuel, disperse, and launch from. That meant runways, taxiways, revetments, drainage cuts, roads, and constant ground maintenance. In the Aleutians, an airfield was not a finished object. It was a surface under continuous assault from weather, water, and traffic. Build it once, and then fight to keep it usable. The D7s worked inside that fight. They cut into wet ground that did not want to hold shape. They pushed fill into low areas, opened access routes through tundra, and helped crews establish the basic geometry of a military base in a landscape that seemed designed to erase machine work. Blade loads changed by the yard. One pass might skim wet volcanic ash and moss. The next might catch buried rock, frozen crust, or a saturated layer with no bearing strength at all. Mechanically, the problem was this. The D7 could produce enough force to move material, but the island often could not provide enough support under the tracks to let that force be used efficiently. Power was not the only question. Ground pressure, drainage, and timing mattered just as much. Crews learned quickly that Adak punished hesitation and overconfidence in equal measure. If they waited for ideal conditions, they would lose the operational window. If they rushed blindly, machines would bury themselves, haul routes would dissolve, and the work would slow anyway. So the construction rhythm became a wartime compromise: push when the ground would take it, shift routes when it would not, lay surfacing where possible, drain constantly, repair continuously, except that every finished section was temporary unless maintained. The weather added another layer of pressure. Fog could shut down visibility so completely that aircraft operations stalled and groundwork became dangerous. Wind drove salt into exposed steel. Moisture found every seam, every bearing surface, every electrical connection around support equipment. Operators worked in heavy clothing, often wet, often cold, with limited shelter and little sense that the island would offer them a stable day. Even in summer, Adak could feel hostile. In winter, it became something else entirely. And yet the build continued because it had to. By August 1943, American and Canadian forces had retaken Kiska after the Japanese had already withdrawn, ending the campaign's major combat phase in the Aleutians. But the infrastructure rush that had driven Adak's development had already consumed men, material, and machines at extraordinary speed. Airfields had been carved out under wartime necessity, not peacetime efficiency. Equipment had been landed to solve an immediate strategic problem. Once that problem changed, the question was no longer how to get machines onto Adak. It was whether it made sense to take every one of them back off. That decision makes sense only if you understand the island's arithmetic. Shipping space in wartime was precious. Cargo priority belonged to active operations. A used bulldozer at the edge of the Aleutians was not just a machine. It was weight, deck space, crane time, labor, fuel, paperwork, and delay. To remove it, crews had to justify not only its remaining value, but the opportunity cost of carrying it instead of ammunition, aircraft parts, food, medical supplies, or newer equipment needed somewhere else. That is how a hard-worked Caterpillar D7 could become surplus in a place that still looked unfinished. Not because it had no value at all, but because the war assigned value differently, and on Adak, that wartime math would leave machines behind. By late 1943 and into 1944, the logic had hardened. The Aleutian campaign had consumed enormous shipping capacity, engineering labor, and machine hours to solve a specific military crisis. Once that crisis eased, the islands were judged differently. Adak still mattered, but not every machine on it mattered equally. The newest equipment, the most adaptable units, and the machines with clear future assignments stood the best chance of being moved onward. The rest entered a harsher category: used hard, far from depot support, expensive to extract, replaceable elsewhere. That is where many wartime machine stories turn quiet. There is rarely a dramatic ceremony when a bulldozer becomes surplus. No final speech, no formal farewell from the operators who had lived in the seat through sleet, fog, and wind. More often, the end comes through inventory language, condition reports, transport priorities, shipping manifests that do not include a serial number. A machine is parked at the edge of a graded area near a supply dump, or beside other equipment judged no longer worth the voyage. Its fuel is drained or left low. Useful parts may be removed first. Batteries disappear, small fittings vanish. Then the weather takes over. On Adak, weather was not background. It was the final owner. A Caterpillar D7 left exposed on that island entered a slow mechanical defeat. Salt air worked into exposed steel and electrical contacts. Moisture settled into housings, joints, and linkages. Freeze-thaw cycles widened every weakness. Track pins stiffened. Rollers stopped turning freely. Seals that were already tired from wartime service gave up completely. Paint failed first, then surface rust deepened into scale. Any canvas, seat material, or rubber component deteriorated quickly under a combination of cold, ultraviolet exposure, and salt-laden wind. What had been a useful military tractor became a static object in stages, not all at once. And yet abandonment in a place like Adak did not always mean immediate destruction. That is part of what makes these machine yards so strange. A bulldozer can remain visibly itself long after it has ceased to be operational. The blade is still there. The track frame is still there. The engine block remains recognizable. The machine keeps its silhouette even as its systems die one by one. To anyone arriving later, it can look less like scrap than interrupted work, as if the operator has only stepped away for a day instead of for decades. That visual ambiguity matters because it explains why forgotten military equipment continues to exert such force on the imagination. The machine still looks ready, even when it is long past recovery. For the men who had worked those D7s, the decision would have felt less mysterious than it appears now. They understood what the machines had endured. Aleutian service was not normal service. These tractors had been run in wet ground, corrosive air, and constant urgency. Maintenance under those conditions was often improvisational by necessity. Crews kept machines alive with field repairs, cannibalized parts, and short-term fixes because the mission required movement now, not perfect preservation later. On paper, a D7 might still exist as an asset. On the island, mechanics knew the difference between a machine that could be revived nearby and a machine that had to justify a long return voyage through wartime logistics. Many could not justify it. Mechanically, the reason was not usually one catastrophic failure. It was accumulated exhaustion. Undercarriages worn by abrasive volcanic ground in constant saturation. Engines still running, but with uncertain compression, contaminated systems, or mounting wear. Final drives and steering components carrying the hidden damage of prolonged overload and bad footing. Frames and blades stressed by years of pushing fill and drainage cuts in terrain that never behaved consistently. Any one of those problems might be manageable in a well-supported shop system. Combined and positioned on a remote Aleutian island, they changed the calculation completely, so the machines stayed. Some remained near former construction zones. Some sat in clusters with other wartime equipment. Some were stripped gradually as part sources for whatever still operated nearby. That secondary life matters. An abandoned bulldozer was not always abandoned all at once. One machine might lose a starter, another a seat frame, another sections of track, another gauges, fuel lines, or injector components. Over time, the yard became its own parts department. Not organized, not efficient, but useful in the way isolated military outposts often became useful, by consuming what they already had. Then the margin disappeared. Once a parked machine was no longer a practical donor and no longer worth transport, it crossed into a final condition. It was not inventory anymore. It was landscape. That transformation is one of the defining patterns of American industrial history in remote places. Equipment arrives under pressure. It works beyond normal limits. The project changes or ends. Extraction becomes harder to justify than abandonment. Then nature and time absorb what industry leaves behind. On Adak, the process was accelerated by climate, isolation, and military secrecy. A row of D7s or parts of D7s could sit in plain sight and still vanish from public memory because almost nobody outside the service had reason to document them carefully at the time. The war moved on. The Pacific moved west. New priorities replaced old ones. and the bulldozers that had helped carve a strategic airbase out of tundra and volcanic ground became leftovers from a solved emergency. What remained was evidence, not just of construction, but of how the United States built under wartime pressure in places where retrieval was never guaranteed. The Aleutians exposed a brutal truth about military engineering. A machine did not have to be destroyed in combat to be lost to war. It could be consumed by distance, weather, corrosion, and logistics just as completely. A bulldozer could survive the assignment and still fail to make it home. That is why Adak matters. It is not simply a story about old Caterpillar tractors left in bad weather. It is a story about the hierarchy of value in wartime, about how strategy can make a machine essential in one year and expendable in the next, about how operators and mechanics can keep steel alive under impossible conditions, only for the larger system to decide that saving it is no longer worth the ship space. The machine did not choose its ending. The war chose it through arithmetic. The site is quieter now. The urgency is gone. The runway work, the emergency grading, the relentless push through wet ground under fog and wind all belong to another era. But the logic that left those machines behind is still visible if you know how to read it. Corrosion marks where maintenance ended. Missing parts show where cannibalization began. The position of a blade or the angle of a parked tractor can tell you whether it was set aside deliberately or simply stopped where its useful life ran out. The machine is gone as a working tool. The consequence is not, because every abandoned wartime bulldozer on Adak preserves a record of what American engineering looked like at the far edge of necessity. Not polished, not ceremonial, not designed for memory, just steel, fuel, mud, and orders carried to the point where retrieval no longer made sense. And that would not be the last time American machines were left behind after doing exactly what they were sent to do.